Hello and welcome to the 4i-magazine podcast. I am Federica Bressan and today we talk about space debris with Stijn Lemmens, a space debris analyst at ESA, the European Space Agency. Welcome to the show, Stijn.
Hi, thanks for having me.
So today's topic is space debris. Let me ask you right away, why is there even debris in space?
Well, that's a very good question to start with, and in its essence, there is debris in space because there's human activity going to space, and space debris is just the leftovers of this activity. We currently have this habit after we've used a satellite, its mission is over, it's done taking pictures of the Earth, to just leave that object stranded there in orbit. And while we do that, we disconnect our telecommunication systems with it, we forget about it, and it becomes susceptible by impact by other satellites which have been left behind, or it explodes because these objects are not designed to spend decades in space. And when that happens, it creates smaller fragments of debris, which also stay up in orbit and which in turn threaten to impact with other satellites. And this is just a cascading event which essentially creates debris in space.
All right, so this is not pieces of rocks. This is stuff we brought up there.
Yeah.
And how much of this there is, and since when? Since the very early missions?
Yeah, essentially, since the first mission went up there, the satellite did not go by itself into space. It brought a rocket stage with it. And this stage, when it delivered the satellite, also remained for a limited duration in time into orbit. So the moment we launched the first satellite, we had the first piece of space debris as well. And these are indeed not rocks, but they're the leftovers of the useful services that they render. There are, of course, also meteorometeorites which pass through the Earth's orbits, but here we are concerned with mitigating the ones we are actually responsible for, rather than the leftovers of the formation of the solar system.
So since the early space missions, it was part of the plan that we would leave some material behind. When did this start being a problem? When did we start thinking that we should do something about it?
Yeah. So indeed, and it was also quite early on realized that this might be a problem. So we're talking the first scientific studies on this that took place in the 80s already. Nowadays, we're talking about an environment of space debris where we have about 30,000 trackable objects. So those are objects which we, from ground, by means of radars or telescopes, can actually follow and predict where they are going to be. You can imagine this as objects of about 10 centimeters or larger in diameter. But they're not the only ones. So if you go a bit smaller, the objects which we cannot see, we're talking, let's say, hundreds of thousands of centimeter-sized objects. And for millimeter-sized objects, we're talking millions, hundreds of millions. And especially these centimeter-sized objects, they are still lethal to a satellite when they collide with it. So we cannot see that. Now, the problem was known since the 80s, and people start thinking about mitigation measures. And around the turn of the millennia, there were so-called space debris mitigation guidelines released to say from, oh, hey, this is the problem. What can we do against it? And they're really not very far-fetched. One of these guidelines is essentially take your stuff out of orbit after you used it. Do it within a limited of time so that you vacate essentially your orbit for the next person there. Now, we have them since the turn of the millennium, and people are starting to adopt them more and more. But the question has been raised, is it already too late? Do we already have too much debris objects in orbit right now to start a collisional cascade effect? And the concerns rise ever faster, certainly in the last 5 years, when you start talking about large constellations being deployed. This can, in theory, work as long as they stick to these guidelines, which are already existing with a high degree of compliance. So be very environmentally friendly, essentially.
Wow, it may even be too late. But listen, has a collision ever occurred? What is the risk of that?
Collisions have occurred. So there was a very famous collision between two satellites, an intact and an active one, 15 years ago, which generates thousands of trackable space debris objects, but also smaller ones where the satellite is hit by a piece of debris that couldn't be tracked. That's, for example, what happened to one of ESA's own missions, Sentinel-1, a couple of years ago, and that in turn created new debris, 8 pieces, which could be tracked in turn. In total, we have about 17 events where either a collision with debris was confirmed or is highly suspected. So it is not, let's say, something which we still have to see. It's something which is already happening.
And so, what's the strategy there? How do you, number one, detect these objects? And number two, what do you do to them? Do you need to bring them down to Earth? Or, I'm saying something silly, but maybe shoot them far away from the Earth?
Space debris has been shot at in the past, so it's not even that silly. But yes, first thing is to detect and track. So at the moment, we see only a fraction of the debris which is out there. And if you are operating a mission right now, you need this information to be able to move out of the way when a piece of debris comes. So we need to bring this limit down on the size of objects we can reliably track from ground. That's one thing. But maybe point zero is we should stop leaving stuff behind after we used it. At the moment, debris is simply being created because we leave it there. If we stop that, it's like closing the tap. Then we can start thinking about cleaning it up. And that is then indeed your third point. Also, my own agency is working actively on missions to grab the large pieces of debris, so the ones who have the potential to create a much more smaller debris, and to demonstrate that we can reliably bring them out of orbit. But I like to stress first stop polluting and then cleaning up. Otherwise, it's just mopping with the tap open.
That can be called pollution, literally.
If
That is
you
space
consider
pollution. We hear a lot about, how we should care for the environment on Earth, but we have already started polluting space. This is what you're saying.
to a certain degree, you can see space as a resource itself. You want to go up there with a mission because you want to take pictures of certain locations on Earth, because you want to monitor the atmosphere. You go up there with a reason, and if you have a spacecraft there, it's at a certain position, it's going around in orbit, it's using a spot. If that object fragments because it's hit by space debris or because it explodes for another design reason, it creates a cloud of debris which will make sure that other objects cannot do their mission in the same spot as before. So yes, this is a resource. And if you are using a resource or making sure that nobody else can use it anymore, then you're polluting to a certain degree. So I think it's a fair point to call it pollution.
And if I may ask, what is your job specifically at ESA? What does a debris analyst do?
Okay. So my job is to essentially connect the dots. I work with people who monitor the debris in orbit, count how many there are, develop how they are created, what are they essentially, and take this information and try to see, okay, what's going to happen on the long term. As you asked before, when do certain regions become unstable? When can I not go there anymore? And take then this information and work together with engineers to effectively design our space missions so that this does not become a problem. So design a mission so that it has enough propellant and the right subsystems on board to take itself out of orbit or to vent its fuel after its mission is over. So we try to make sure that this is actually a loop between the scientists monitoring the debris, so the engineers developing new missions, and all the stakeholders who in the future want to go into an environment, that they're well aware of the risks and that they do not repeat the mistakes of the past. That is what a debris analyst does.
Thank you very much for sharing this information with us today. I would like to thank you for being on the 4i-magazine podcast. I would like to invite the audience to check out the ESA website to learn more at esa.int, and also to check out the 4i-magazine YouTube channel to find more episodes of this podcast. I'm Federica Bressan, and I will see you next time. So long.